cosines. So you can see we have three versions of the law of cosines up here. They're all solving for a different side. Noting that when we're solving for side a squared, we're using the angle over here, cosine of a. We're solving for b squared, we're using the cosine of b. And when we're solving for c, we use the cosine of c. So you read through those versions, a squared equals b squared plus c squared minus 2bc times the cosine of a. B squared equals a squared plus c squared minus 2ac times the cosine of b, and so on. Basically, what you'll use is the law of cosines for probably when you don't have enough information to use the law of sines. So it allows us to solve triangles when we don't have one of our ratios filled out in the law of sines, and then we could go ahead and apply one of these law of cosines, knowing these three versions, that we use the other two sides squared minus 2 times those two sides and the angle is between those. So we'll start out today actually with a word problem. Surveyor wishes to find the distance between two inaccessible points A and B on opposite sides of a lake. While standing at point C, she finds the distance between A and C is 259 meters. The distance between B and C is 423 meters, and angle C is 132 degrees and 40 minutes to find the distance between A and B. So we have points A and B. We'll just put random points A and B on here somewhere. Really doesn't matter where. And we'll put point C out here somewhere as well. And we'll label the distances here as we go. Standing at point C, the distance between A and C is 259. So we'll put B and C. So the distance from A to C is 259 meters. Distance between B and C is 423 meters, and angle C in here, angle C is 132 degrees and 40 minutes. Well, you can see here we're going to try and find this side. I'm going to label it as side A. Nope, no, I'm not. I'm going to label it as side C since it's opposite angle C, which would allow me or tell me to use this version of our law of cosine. Now before we get to that, let's take a look here real quick and see why we would use the law of sines. Opposite angle A is 423. We don't know angle A. Opposite B is 259. We don't know angle B. We don't know angle C or side C, but we do know the angle is 132 degrees and 40 minutes. So from here you can see that if we cross multiply with any two sets of our ratios, we're going to have two variables. We can't solve one equation with two variables, so the law of sines does not work here, but the law of cosines does, because we can solve for C. We can say C squared equals A squared, or 259 squared, plus B squared, or 423 squared, minus 2 times A times B, times the cosine of the angle C, which is 132 degrees and 40 minutes. If we plug that into our calculator, we would get C to equal, or C squared, would equal about 394,510.5693 meters. Keeping in mind we solve for C squared there, we want to know what C equals. So C equals about 628 meters as we use our law of cosines. And there will be our opening problem, word problem, drawing our triangle, although the lake and that kind of information really wasn't all that important. It just drew a triangle for us. Again, same thing with the law of sines, the law of cosines. We don't need a right angle here. Notice we didn't have a right angle through our triangle. Our law of cosines will work with any triangle, and probably more specifically when we don't have enough information for the law of sines. So we'll go ahead and do that without the word type and just say solve the triangle. If angle A is 42.3 degrees, angle or side B is 12.9, and side C is 15.4. I'm going to start the same way by saying, or setting up our law of sines. We have A over the sine of 42.3 degrees. We have B over the, let's try that again. We have 12.9 over the sine of angle B, and we have 15.4 over the sine of C. Once again, noting that we don't have enough information to cross multiply with any of these ratios, at least here initially, so we'll move to our law of sines. Since we have sides B and C, we'll go ahead and solve for side A first. So A squared equals B squared, 12.9 squared, plus C squared, 15.4 squared, minus 2 times B times C times the cosine of the angle of 42.3 degrees. And we could plug that into our calculator and we would get A to be about 10.5 meters. Now when we get to this point, we do actually have choices here. We could use our law of sine, so I could come up here and say side A is 10.5, and now I could cross multiply and solve. The one thing I would point out here, if we do have to keep in mind the ambiguous case, so if you're going to use those law of sines, make sure your angles and your sides match up. And when I say match up, I mean in relationship to size. We should all know by now the largest side should be opposite the largest angle. The smallest side should be opposite the smallest angle. So when we solve this, 10.5 should be 42.3 should be my smallest angle in here because 10.5 is my shortest side. If it doesn't happen, then we have to go back and try our ambiguous case by subtracting from 180 and what we talked about on the previous lesson. So I'm going to start out by solving for the sine of B. 10.5 times the sine of angle B equals 12.9 times the sine of 42.3 degrees. If I divide by 10.5, I'm going to get the sine of angle B equal to a decimal value. I guess I don't have that written down here. I just have the angle, so I'm going to wind up using my inverse function to say angle B is equal to about 56 degrees. So notice 12.9 is larger than 10.5, and 56 degrees is larger than 52.3 degrees. And we could repeat the process with the first and last ratio. So I'd have 10.5 times the sine of C equals 15.4 times the sine of 42.3. Divide by 10.5. And that will allow us to solve for angle C to be about 81.7 degrees. And once again, noting 15.4 is my largest side, 81.7 degrees is my largest angle. So this all works out where we've solved our right, or not our right triangle, solved our triangle. We'll go through this one more time, so hopefully it's pretty clear. Here, solve our triangle. If A is 9.47, B is 15.9, and C is 21.2. Starting the same way with our law of sine, it should be pretty obvious that as we write these down, we have a variable in each ratio, and so we can't find anything by cross multiplying because we don't know any of the three angles. So this is going to be a little bit different. We're going to use our law of cosines, but now to solve for one of our sides, or one of our angles. So I'm going to use the a squared equals version. So a squared is 9.47 squared equals 15.9 squared plus 21.2 squared minus 2 times 15.9 times 21.2 times the cosine of angle A. So notice we're going to solve for the cosine of angle A this time rather than one of our sides. If we go ahead and do the math on that, I'm going to go ahead and show that on the calculator here real quickly, possibly. So we have 9 point, maybe, not working here. Well, apparently that's not going to work. Oh, there we go. So we'll go 9.47 squared. From that, we're going to subtract 15.9 squared and 21.2 squared. Once I have that number, I'm going to divide it by -2 times 15.9 times 21.2, and that would give me a decimal value. That's my cosine of B, or cosine of A, equals that number. So I convert that ratio to an angle by using my inverse function for inverse cosine of that value, and you can see the angle A equals about 24.7 degrees. So that's what I'm going to write over here. Angle A equals 24.7 degrees. Now we'll just go ahead and go through the same way. I'm going to solve for all three of my angles by using the law of cosines. I'm going to reverse this now and use B, so 15.9 squared equals 9.47 squared plus 21.2 squared minus 2 times 9.47 times 21.2, and now we're solving for the cosine of B. Noting I had side B over here, so I'm solving for side B over, or angle B over here. And I'll show this one more time. So I have 15.9 squared. From that I'm going to subtract, in parentheses, 9.47 squared and 21.2 squared. Then I'm going to divide that, in parentheses, by negative 2 times 9.47 times 21.2. Gets me my decimal value I need to convert to an angle, so I use my inverse function, second cosine of that angle, and we get about 44.5 degrees for angle B. We have two choices here. If we know I have A and B, we could just add those two together to get C. I'm going to go ahead and write it down just so we can see this law of cosines one more time. 21.2 squared equals 9.47 squared plus 15.9 squared minus 2 times 9.47 times 15.9 times the cosine of angle C. And if we went ahead and either plug this into our calculator to solve or added these two together and subtracted from 180, we should get about 110.8 degrees, and those are our three angles. Now, as we may have figured out, once I had angle A, I also have a choice up here. I could put 24.7 degrees in here and now cross multiply to solve for angle B and cross multiply to solve for angle C. But with that in mind, with three sides there and only one angle, I do have to worry about that ambiguous case with the law of cosines. That is not an issue. We can just do our work here, and our angles will always be correct as long as we've typed our information correctly. With our law of sines, we have to worry about whether or not this is, we could say we solve for C first. We might get a smaller angle, such as, what would that be, about 69.2 degrees, which would be the ambiguous case, because obviously C is not 69.2, so we have to subtract that from 180 and go through that work. So the law of cosines, at least in my opinion, works much better than transferring the law of sines, even though law of sines does look easier.